All right, so welcome back. So in this example, we're going to start to look at graphing curves in polar coordinates. And in this first example, I am going to go brute force overload. So what I've done here is I've taken, and I'm looking at the function here, r equals cosine theta plus 1. And what I've gone ahead and done is I filled out my table, looking at the angles, starting at 0 degrees or 0 radians and working my way around the circle. So pi over 6, 30 degrees. Then pi over 4, pi over 3, all the things we kind of associate with our basic values. Now we know the exact values, but we're graphing them, so I'm using decimal values. All right, pi over 2, and then we keep coming. Where pi over 3 is a reference angle, b2 pi over 3 would be the next one, 120, then 150, 135, then 150, finally 180 degrees. Right, and just computing this expression for every one of those. And then continuing to the third quadrant. 30 degree reference angle would be 210, 225, 240, and then finally at 270. And then 300 degrees, 315 degrees, 330 degrees, and 360 all the way around the circle. So all I've done is I've just computed all of these. Now, usually we don't need to have quite so many values to graph these. I'm going to show you ways that you can graph these without nearly as many points. So we're going to be looking at that. But I wanted to use this first example here with all of these points so you can kind of get a little feel. And if you're ever stuck, plot a few more extra points, right? And I want you to get the feel for how a circular graph works and how to connect things in a circular graph. So that's why we're plotting so many points here. So now we're going to come down here, we're going to use graph paper. My recommendation is use some version of polar graph paper. You could do a quick Google search for polar graph paper. And just go to the images. So here I've just done a quick little search here on Google for polar graph paper. And then find an image that gives you a decent thing and start printing some stuff out. So this is a pretty decent image. Actually, apparently it's free printable graph paper. Not sure. Here, finally put it out. So there you go. You can print your own graph paper out. And this is nice because it's 15 degree. And that's usually pretty good ones. And I think this one said it had 10 subdivisions of the little circles as you build out. So that's a pretty decent one right there. And you just print yourself, some sheets of graph paper out. Of course, if you want, you could copy that image and paste it in a couple of times into a Word document, right? So that you could have, on a sheet of paper, you might have 3 or 4 graphs that you can then print out, or more, however you want to do that. But get yourself some polar graph paper. And so I'm using an image here that I've taken from an app that I have. Right there you go. Again, that was like one of the very first options that I clicked. And it lets me print that right out. Okay, so what I've done here is my graph paper has actually 8 circles, 8 concentric circles that I can use for different radiuses. Since my values were ranging between 0 to 2, I opted here to take each circle and make it a quarter unit since I had 8 of them. Right, each circle and make that into a quarter unit. Okay, and then my angles are also marked, but unlike the graph paper I've just showed you, they're not labeled. But it's pretty easy to see what's going on here. Right, there's your 90 degrees or pi over 2. There's half of pi over 2. This is also 15 degree graph paper, so there's your 30 degrees or pi over 6, pi over 12, right? There's your 60 degrees or pi over 3. So all the values are there, they're just not labeled. So let's go through and start graphing some of my points. My first point here is 2, and then I have a 1.86 at 30 degrees, a 1.7 at pi over 4, and a 1.5, and then finally a 1 at pi over 2. So let's just focus on that group right now, and let's go ahead and look at how to graph those. So the first would be an angle of 0 radians, and we would be a distance 2 away. So that would land us at this point. The next point we had was pi over 6, which is 30 degrees, and 1.86. So I'm going to come over here on my graph. Right, there's the 1.75 circle. And so 1.86 is going to be between 1.75 and 2. So I'm going to kind of estimate that it's a little closer to the 1.75, so there we would mark that. Then I have 1.7, that would be just a little bit past the 1.75 circle. And then at 60 degrees, I'm at 1.5. And then finally at 90 degrees, or pi over 2, I'm all the way down to 1. So I'm going to go onto my 1 circle. Now, how do we connect these points? How do we connect these points? Do we just draw straight lines to them? Well, this is how you want to think about it. I think about polar graphing as standing inside of a cornfield. You've heard the expression, the crop circles and stuff in the cornfields. Well, I like to think of it as standing in a cornfield with a lightsaber. The lightsaber would be cutting out swaths of corn. You could stand in the lightsaber if you turned in a circle, or if we just did a circle of radius 1, then we stood and turned in a full circle, right? Then we would cut out all that stuff. That would all be gone. Right, and the outer edge would just be that circle of radius 1. Well, let's think of our lightsaber as being a little bit more precise, that we can actually alter the length of the lightsaber. And then what we're looking at in polar coordinates is we're looking at the shape that we're cutting out. So what we realize is as I start turning around, if I'm standing at the middle with my lightsaber, turning around, I'm going to come through that point. And of course, it's always getting smaller. It's continuing to decrease, right? The radius is getting smaller. And so you have this circular motion here. And that's what we're going to do, is connect that with a nice circular motion. So, all right, and then we're going to continue now as we go into the second quadrant. Looking at our values here, we're down to a half, down to 0.3, 0.14, down to 0. Okay, and those are happening at my 120, 135, 150, and 180 degrees. Okay, so at at 120 at a pi over 3 reference angle, we would be on the half, so that would actually land us right there. The big one, of course, is the 45 degrees. We know that's down to 0.3, so that's just a little bit above the 0.25 circle, and then we're down to 0.14 at the next one. Again, that's a little closer, and then we would be down finally to 0. Okay, and we're going to connect all those things again with a circular curve. So coming out like maybe something like that. Or we have something that looks about like that. Okay. And then we would continue with our other 2 quadrants. And what's going to happen is in the third quadrant, we're just going to kind of have a repeat of what we just did. And then in the fourth quadrant, kind of a repeat of what we had in the first quadrant. Okay, So let's just go in and quickly mark off those as we go in our polar graph. So 0.14 at the 30-degree mark, okay, out to 0.3, out to 0.5, all the way out to 1. Did I go too far? No, that's great. Okay, and then again, do my best to kind of connect those with a circular path. Okay, like so. And then we have just the last little bit there, 1.5, 1.7, and 1.86 to finally to get back to 2. So we go back again to the 60-degree mark. We're going to be at 1.5. We'll go on the 60-degree mark. Okay. And then 1.7 when we get to the 45 degrees. So again, that's going to be just a little short of the 1.75. And finally 1.86, which again is closer to the 0.75 than it is to the 2. And then finally we're back to 2. And so again, as we're coming out, it's growing, 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 growing until we reach 2. And so now we have managed to draw the graph of what I always think of as a plumber's crack, honestly. It looks like a butt. Right? This looks like a butt to me. The actual shape, though, is actually called a cardioid. And that's its actual name, is a cardioid. So there you have it. We've graphed our first equation. We've graphed our first equation in polar coordinates. Now, we're going to look at how to do this so that we can not have to do quite so much plotting of points. But again, I mean, it's there, and really that's not a terrible thing because you can easily generate a table menu. In fact, here you could even, almost set it up. You can even go, if you're doing 15-degree graph paper here, or you could actually set these up with an increment starting at 0 and going up by pi over 12 so that you hit every one of the 15-degree marks, right? And then it's just a matter of graphing them and connecting them. But we're going to look at an easier way because we'll be able to say, hey, it's going from 2 down to 1. So I know it's going to fall as I'm coming around here, so I just keep getting smaller, and we kind of can estimate the graph. We're going from 1 to 0, so it's going to fall. We're going from 0 to 1. We're going from 1 to 2. All right, so we can do things like that to really cut down on how much graphing we actually have to do, how many plotting of points we have to do. So we'll talk about that and look at that in some examples in our upcoming problems.